Bismillahirrahmanirrahim. Welcome to lecture number 6 of data science. We will continue our discussion on introduction to programming in Python. So this is the discussion agenda. We will see classes and objects in Python. We will see lambda functions. We will see NumPy library. And we will perform different NumPy operations on NumPy arrays. So let's continue. We go to our Jupyter notebook. So here we start the Python programming language objects and map. An example of a class in Python. So we have a class person. We have a variable department, school of information, a class variable, and we have a method def set name self new name. Self.name is equal to new name, and def set location self new location. Self.location is equal to new location. If I do shift enter, so nothing happened because we have not created any objects. So we can create an object person. This will call the constructor of the class. So person.set name, this is name. Person.set location, this one, and we print this one live in this and works in this department. So dot format person.name, person.location, person.department. So it will print like this: Christopher Brooks live in this location and works in this department. Here is an example of mapping the min function between two lists. So let's say we have two lists, store1 and store2, and we want to know which one is the minimum. By looking to the values of store1 and store2, store2 is minimum because this value is less than this one, this is bigger, this is same, this value is less than this one. So we can do cheapest map min store1 store2, and we print cheapest, and it gives us a map. But what are the values of this cheapest? We can iterate through the map object to see the values. For item in cheapest, print item. So you see 9. This one is minimum 11. So 11 is picked. 12 by 0.34, 2.01. The Python programming language, lambda and list comprehension. So here is an example of lambda that takes in 3 parameters and adds the first 2. So my function is equal to lambda a comma b comma c colon a plus b. My function 1 2 3. So let me execute this one, and let's execute this one, and it returns the sum of 1 plus 2. Let's iterate from 0 to 999 and return the even numbers. So my list is equal to empty list for a number in range 0 to 1000 if number modulus 2 is equal to 0, it means it's an even number. So we return my list dot append number, and we print my list. So you see all the even numbers are printed starting from 0 to 999. Here is the same thing but with list comprehension. My list is equal to number for a number in range 0 to 1000 if number modulus 2 equal 0, my list, and it prints number 0 to even numbers. The Python programming language, numerical Python, or NumPy. So import NumPy as NP. We can create array creating a list and convert it to a NumPy array. MyList is equal to 1, 2, 3, np.array mylist x, or just pass a list directly. So np.array 4, 5, 6. Pass in a list of lists to create a multi-dimensional array. So this is one dimensional, 7, 8, 9. This is another dimension, and we create a two-dimensional array M. Use the shape method to find the dimensions of the array. The first element gives you rows and the second element gives you columns. M.shape 2 rows 3 columns. Average returns evenly spaced values within a given interval. So np.array 0 to 30 by interval 2. It starts at 0 and count up by 2, stop before 30. You can print n and you can see the values 0 to 28. Reshape returns an array with the same data with a new shape, is 3 by 5. So the same elements are reshaped as 3 rows and 5 columns. Linspace returns evenly spaced numbers over a specified interval. So np.linspace 0 to 4, and so return 9 evenly spaced values from 0 to 4. 9 evenly spaced. So 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. These are total 9 values, and in the interval of 0 to 4. Resize changes the shape and size of array in place. So it's the same as 3 by 3, but the difference is this one we need to assign to O, and this one we can just reshape it. Ones returns a new array of given shape and type filled with ones. So np.ones 3 by 2. 3 rows, 2 columns. Zeros returns a new array of given shape and type filled with 0. 2 by 3. 2 rows, 3 columns filled with 0. I returns a two-dimensional array with ones on the diagonal and 0 elsewhere. So np.I, it returns 3 by 3. Yes, 3 by 3, but I function is in the diagonal, there are ones. Diagonal extracts a diagonal or construct a diagonal array. So if we do np.diagonal y, it will print like this. And if you remember, if you print y, so that was y, it was a one-dimensional 4, 5, 6, and then it returns to a two-dimensional diagonal array. Create an array using repeating list or see np.tile. So np.array 1, 2, 3 repeated by 3. Repeat elements of the array using repeat. So repeat 3, np.repeat 1, 2, 3 by 3. 1 is repeated 3 times, 2 is repeated 3 times, 3 is repeated 3 times. We can combine arrays. So np.ones 2, 3 integer is a 2 by 3 ones array, ones matrix, and we can use vstack to stack arrays in sequence vertically. It means row wise. So first we put on p and then 2 to the power p is vertical stack. We can use hstack to stack arrays in sequence horizontally. So np.hstack p to power p. We can use plus, minus, multiply, divide and power to perform element-wise addition, subtraction, multiplication, division and power. So we print x, y, and we print x plus y and x minus y. So you see, this is x, this is y. X plus y is 4 plus 1 is 4, 5 plus 2 is 7, 6 plus 3 is 9. And then 1 minus 4 is minus 3, 2 minus 5 is minus 3, 3 minus 6 is minus 6. We can do x multiplied by y and x divided by y to perform element-wise multiplication and element-wise division. So 4 multiplied by 1 is 4, 5 multiplied by 2 is 10, 6 multiplied by 3 is 18. And 1 divided by 4 is 0.25, 2 divided by 5 is 0.4, 3 divided by 6 is 0.5. We can perform the element-wise power. So x to the power 2 is 149. Remember, x is 1, 2, 3. And the dot product is different than the element-wise multiplication. You remember the dot-wise product of two vectors. So the number of columns, the number of rows of the first matrix or vector must be equal to the number of columns of the second vector or matrix. So if we have like this, it will be x1 y1 plus x2 y2 plus x3 y3. So x dot dot y product. So you can print x and y to see for yourself. Print. So 1 multiplied by 4 plus 2 multiplied by 5 plus 3 multiplied by 6, and the value becomes 3. So the dot product becomes as the 1 by 1. So it's the number of rows of the first to the number of columns of the second. Okay, so we have this np.array y to the power 2. We can print z and we can print the length of z. So y is 4, 5, 6, y to the power 2 is this one, and the length is, so the number of rows of the array is represented by the length. Let's look at transposing arrays. Transposing permutes the dimension of the array. We have z, np.array, y to the power 2, and we print z, so it is this one. And z.shape is 2 by 3, and we can use dot t to transpose the array. So you see these 4, 5, 6 become the columns 4, 5, 6. 16, 25, 36, 16, 25, 36. The number of rows has swapped with the number of columns. If you print the shape, so it's 3. It was 2 by 3. Now it is 3 by 2. We can use the d type to see the data type of the elements of the array. So z.d type, it's integer. We can convert it to another type. So you can use as type to cast to a specific type. Z.as type f, z.d type is a float 32. NumPy has many built-in math functions that can be performed on arrays. So let's say we have an array A, np.array -4, -2, 1, 3, 5 is one array A, and a.sum will add elements of the array. So -4 -2 is -6, 5 plus 1 is 6, so 6 minus 6 is 0, plus 3, a.sum 3. A.max will return the maximum element of the array, which is 5. A.min will return the minimum, which is -5. A.mean will return the mean value, which is 0.6. A.std will return the standard deviation, which is 3.2. Argmax and argmin return the index of the maximum and minimum values in the array. So a.argmax is 4. The maximum element is 5, so its index is 4. 0, 1, 2, 3, 4. Similarly, a.argmin, it returns 0 because the minimum number is at index 0. We can do indexing or slicing. So let's say we have an array 13 to the power 2, so 13 elements, and every element is in the power of 2. So 0 power 1, 1 power 1, 2 power 2, 3 power 2, 4 power 2, and so on. So these are total 13 elements. You can use bracket notation to get the value at the specific index. So for example, S at index 0, S at index 4, and the last element. We can use colon to indicate a range, array, start, stop. Leaving start or stop empty will default to the beginning and end of the array. So begin at 1 and stop at 5. So 0, so this is 0, so we start from 1, 2, 3, 4, not including 5. Use negatives to count from the back. So from the back up to the last fourth element. So you see 114, 121, 181. A second colon can be used to indicate step size. Array, start, colon, stop, colon, step size. Here we are starting fifth element from the end and counting backward by 2 until the beginning of the array is reached. So from the end, fifth element from the end, go backward until the beginning of the array is reached. So it's 64, 36, 16, 4, and 0. Let's look at a multi-dimensional array. So we have np.arrange 36 and we resize it as 6 by 6. So it's 36 element and we reshape it or resize it as 6 by 6. We can use bracket notation to slice array, row, column. 2 by 2. 2 by 2 is here 14. So it will give us 14. We can use this to select a range of rows or column. So 3 means the third row, and 3 to 6. Column number 0, 1, 2, 3, 4, 5. So 21, 22, 23 should be printed. Here we are selecting all the rows up to and not including row 2, and all the columns up to and not including the last column. So let's say we do print R. All the rows up to row number 2. So all the rows up to row number 2 are this one, and all the columns up to the last column. So 0 to 4, 6 to 10. This is the slice of the last row and only every other element. Last row and every other element 30, 32, 34. We can also perform conditional indexing. Here we are selecting values from the array that are greater than 30. We can also use np.where. So print R if R is greater than 30. So which values are greater than 30? These values are greater than 30. Here we are assigning all the values in the array that are greater than 30 to the value 30. So print R. All those values that are greater than 30 are assigned 30, and we print 30. Be careful with copying and modifying array in NumPy. So we take an R2, that is a slice of R. So this is R, and we take R2 as everything to the third and everything to the third, and this is third row and everything to the third column, give us this slice. Now I change the slice R2 to 0. R has been changed to, you see. So to avoid this, we can use r.copy to create a copy that will not affect the original array. So r underscore copy is r.copy, and we print r copy. Now I change r copy everything to 10, and we print r copy and r. So you see r underscore copy is a different matrix and r is a different matrix. Let's create a new 4 by 3 array of random numbers 0 to 9. So np.random random integer 0 to 10 4 by 3, and we print test 4 rows 3 columns, all values are from 0 to 10 and all values are integer. Now we can iterate by row. For row in test, print row. For column, for I, iterate by index. For I in range length of test I, or iterate by row in index I and row in enumerate text. Row I is row, this one. We can do zipped to iterate over multiple iterables. So test2 is equal to test power 2, and we print test2. And we can do for I, j in zip test2, we print I and j and I plus j. So I is coming from test and j is coming from test2, and both elements are added together. Okay, so we are going to start a new topic, the series data structure. So this notebook has some requirement, some different packages that need to be installed. So how we can perform that? Pip freeze and requirement.txt. Requirement.txt has all the requirement of the packages that need to be installed. So once you install that, you can use pandas. Pandas is a series data structure. So import pandas spd pd.series, and actually so this is the definition of series data structure. You can go through it and study for yourself. And let me just clear it, the output. So okay, so once we have this one and we close this one, now we have animals: tiger, bear, moose. So pd.series animal, it will make a series. Position 0 is tiger, position 1 is bear, position 3 is moose. Now we can use numbers 1, 2, 3, and pd.series numbers, it will make numbers 1, 2, 3. We can use the animal as 1 is none, and pd.series animals, it's tiger, bear, none. Or we can have number 1, 2, none, and in numbers none is not a number. So we can use import numpy as np. np.nan is equal to none. Is it the same? The answer is no. So np.nan equal nan is also false. np.isNan, np.nan, oh, this one is true. So make sure that what you are comparing for. So let's say we have sports, archery, Bhutan, golf, Scotland, sumo, Japan, taekwondo, South Korea. And pd.series sports, and we print s. So the keys are the game name and the values are the country name. We can do s.index. So these are the indices and its type is object. Let's say we have series tiger, bear, moose, index India, America, Canada. So countries are keys and animal names are the values. Let's say we have this one, sports, the same as this one, index golf, sumo, hockey. Golf, sumo, hockey. And the laws starting from the golf. So we have golf, sumo is Japan, and hockey is not there. So we leave hockey as nan. Querying a series. Let's say we have sports, and we make it a series. So we already studied this. S.I location 3. So who is at I location 3? 0, 1, 2, 3 is South Korea. Who is at location golf? Scotland. S3, South Korea. S golf, Scotland. Let's say we assign it 99, 100, 101, 102, and we make a series sports. So S0, this will not call S.I location 0 as one might expect. It generates an error instead. So what we can do, this is pd.series 100, 120, 101 and 3, and we can add these elements to make it 324. We can perform this with np. Import numpy as np, np.sum s, and print total is the same as above, 324. Let's do this. Creates a big series of random number 0 to 10,000, and let's say sp.head. So we have 0, 1, 2, 3, 4, 500, 56, 700. So only the head is printed from 0 to 4. The length of s should be 10,000. We can time it minus n 100 and summary equals 0, summary plus equal item. So it's 2.53 millisecond plus minus 583 microsecond per loop. We can the sum operation The slowest run took 5.53 times longer than the fastest. This could mean that the intermediate result is being cached 373 microseconds per loop, and we can do S. I think we will continue this discussion in our next lecture. For now, it is enough. Thank you very much.